Dear children, good morning. Today we are going to start a new chapter, chapter number 3. Alright, and the name of the chapter is Energy. Alright, so name of the chapter is Energy. We are going to learn about energy here. Alright, so what are we going to learn here is, here you can see what is energy, types of energy, transformation of energy. So these are the three main topics. Okay, these are the main topics which we are going to learn under this chapter number 3, energy. Okay, first of all, let us learn what is energy. Now you know that whenever you are asked to do some work, or whenever you are playing football, volleyball, or any other activities that you are doing, you need some energy, and after playing for certain duration you get tired, isn't it? Means you are using up energy. So energy is used to do some work. Alright, understand? So to do work, it means you need some energy. So here it says you feel tired of your work continuously for long time, isn't it? When you are doing for long time, when you are tired, you will have less capacity to do work. So therefore now you can underline this here. From here, the capacity to do work is called energy. So what we call to energy? So energy is the capacity of a body to do work. So energy cha bhane you can do the work, isn't it? So as you do work, your energy gets reduced. Okay, so we eat food regularly to get the required amount of energy. So from where we are getting the energy? We are getting the energy from the food that we are eating, isn't it? Similarly, the car gets its energy to run its engine from the petrol, isn't it? The your mother cooks food by burning gas, isn't it? So heat energy from the gas is coming after burning the gas which comes in the cylinder. So whenever you need some energy, what happens? You need some source, right? So the source of our energy, our body gets energy from the food that we eat. So hence energy can be defined as the ability to do work. Requirement of energy is different for different people. Someone like an athlete, cricket player, wrestler, boxer, football and hockey player needs lot of nutritious diet, as he or she needs a lot of energy to perform his or her tasks. So depending upon your activity, you have to intake the amount of food, more or less. So if you are a sports person, if you are playing lots of games, then you have to intake lots of food to get energy, because when you do some work or some activity, your energy gets reduced. All right, now as you know, in physics, whenever we are learning some physical quantity, today's physical quantity is energy. So it has to be measured, and when it is measured, it has to be expressed in some unit. So that there are two main units. Okay, that is joule and calorie. So the two main units of energy are joule and calorie. Out of these two, joule is the SI unit of energy. This is the unit which is used all over the world, that is SI. Whereas calorie is especially used to express the energy given from the food. फुडबाट पाएको एनर्जीलाई चाहिँ केमा नाप्छ? क्यालोरीमा. Whereas other energies are usually measured in joule. Okay, joule is the common unit of energy to which all energies such as so such as kinetic, potential, electrical, chemical, etc. are measured. All right, so on the other hand, calorie is unit which is primarily used to measure the heat energy or energy contained in food. So as I've said you here about food, isn't it? All right, so underline this also. The unit joule can be defined as follows. So this is the definition of joule. When a power of 1, underline this, 1 watt is used for 1 second, the energy consumed is said to be 1 joule. So whenever I say underline, you can pause the video. You pause the video, you underline, again you play, so that you do not miss my lecture. Okay, so what is 1 joule? 1 joule is said to be the energy consumed when power of 1 watt is used for 1 second. Now what is watt? Here you have this term called watt. Now watt is the unit of power. Power ko unit चाहिँ watt, denoted by capital letter W. All right. The unit joule is used in the honor of great scientist, English scientist James Prescott Joule, So joule is a unit that has come from the name of a scientist, English scientist, whose name was James Prescott Joule. Understand? Now bigger units are kilojoule, kj, and megajoule, mj. So you must remember that how the units are written. Here kilojoule is written in this way, small letter k, capital letter j. You always have to write in this way only, okay? Because if you write, okay, let me write here on the top, if you write capital K and capital J, this capital K means unit of temperature, that is Kelvin. It does not denote kilo. Okay, so to denote kilo you must write in small letter K. Okay, then megajoule, the unit is mj. Clear? Now here is the relation. You underline this and learn this, that 1 kilojoule baneka is 1000 joule, which you can write in 10 to the power 3 joule. Okay, 1 megajoule means 1 and 60 joule. Okay, that is 10 to the power 6 joule, and 1 calorie equals to 4.2 joule. Very important. So put a star mark here and mark this. 1 calorie equals to 4.2 joule banera. Okay, now relation between work and energy. What is it? Relation between work and energy. When we do any work, energy is needed. So energy goes on decreasing as we go on doing work. Why? Here is the answer. When we do, okay, work, okay, our energy will be utilized or spent in doing the work. Thus there is a direct, okay, direct relationship between work and energy. We can say that work and energy are the, okay, two same, okay, two sides of same coin. So this picture does not have that last sentence of the paragraph. Okay, so they are just like the two sides of a coin. Okay, a coin ko, it has head and tail, isn't it? Yes, so they are part of the same what coin. Clear? So when you do work, you need energy. When you are spending energy, which means you are doing some work. So they are this is how they are related. Now here in this in the next thing column here, you can see that there is a topic called more to know. Now let's learn them. When an object is in motion, some energy is associated with it. This energy associated with moving object is called kinetic energy. Please remember, kinetic energy. Kinetic bhaneko नै motion. So whenever you see that something is moving, when you are writing your right now you are maybe underlining, so your hand is moving. So your hand, when it's moving, it has kinetic energy. When the wind is blowing, it has kinetic energy. When the fan is rotating, it has kinetic energy. When the wings of the birds are flapping, it has kinetic energy. So when you see that whenever something is in motion, जुनै पनि कुरो मोसनमा छ, हल्लिँदैछ, it possesses kinetic energy. All right. So kinetic energy is the energy possessed by a body which is in motion. Kinetic energy are of three types here. They are translational kinetic energy. Translational means to translate, to transfer. So whenever energy possessed by a body is moving in a straight line is called translational motion, in a kinetic energy. Then the energy possessed by a body which is rotating on its own axis is called rotational kinetic energy. See, here you see a car can travel from one place to another. So a moving car has translatory or translational kinetic energy because it is getting transferred from one place to another. It is moving. At the same time, it is moving from one place to another. त्यति बेला भएको energy लाई we call it as translational kinetic energy. All right. But if you see a fan can rotate. It is moving. It is in motion. Fan is in motion, but it does not change its place. It is fixed, isn't it? It is fixed on the ceiling. Understand? So such kind of energy possessed by a moving body which is rotating about its own axis. आफ्नै एउटा पोइन्टमा वरिपरि घुमिरहेको बडीमा भएको एनर्जीलाई त we call it as rotational kinetic energy. Energy possessed by a body vibrating about its mean position is called vibrational kinetic energy. So the third type of kinetic energy is, so you underline all this through kinetic energy. You pause the video and underline, okay? The energy possessed by a body which is vibrating, जुन चाहिँ त हल्लिँदैछ, घुमेको पनि छैन तर हल्लिँदैछ. Are you getting my point? They are called, or the energy possessed by them are called vibrational kinetic energy. For example, sound box. If you see the sound box, what is happening to the sound box? The speaker, the membrane of the speaker gets vibrated. So the energy possessed by it is vibrational kinetic energy. When you are playing a drum or when you are playing a guitar, you strum the string of a guitar. हैन गिटारको स्ट्रिङ तान्यो भने के हुन्छ, स्ट्रिङ गेट्स भाइब्रेटेड, तलमाथि हुँदै हल्लिन्छ. So such kind of energy, okay, possessed by a body which is vibrating is called vibrational kinetic energy. All right, is that understood? Okay, now here you have one more topic called enrichment. All forms of energy are associated with motion. For example, any given body has kinetic energy if it is in motion. A tensioned device such as bow or a spring, thought at rest, has the potential or creating motion. It contains potential energy because of its configuration. Similarly, nuclear energy is potential energy because of the result of the configuration of subatomic particles in the nucleus of an atom. So your paragraph, what does it say is that whatever may be the energy, form of energy, it has something to do with motion. Are you getting my point? So all forms of energy, whatever may be the energy, all forms of energy, sound energy, heat energy, light energy, magnetic energy, whatever may be the forms of energy, all this energy can be related or associated with motion. Understand? So at the end, all energy can be converted into kinetic energy. Okay, so this is the first page of your chapter. Here you have the introduction of the energy. Okay, I guess now you have understood what is energy, the units in which we measure energy, types of energy we'll do in the next class. Alright, so that's all for today. Now after you finish watching this video, you'll get some work to do, okay, as usual. Okay, you'll get some question and answers based on the explanation I've done today. Alright, which you have to copy in your copies with a very good and neat handwriting. Okay, and then obviously you have to learn it. Okay, that's all for today. Thank you.